Okay, a main focus of the CeBIT Global Conferences this year is solutions for a smarter world. How can we use innovations in IT, for example, what we just heard, to help improve the way companies run across the board? Better companies make for a smarter world. Well, our next speaker is a man who brings impressive technical, business, and IT experiences to the table. He combines them in his current position, and today he's here to list out smart solutions for our energy-hungry world. Please help me welcome to the stage the Executive Vice President at Shell for Technical and Competitive IT, Mr. Arjen Dorland.
Hallo.
Hello.
Guten Morgen. Good morning. Wir können auch in Deutsch tun, aber English war die Sprache, also tun wir es in English heute Morgen. Welcome also people on the video stream. It's a big pleasure for me to be here on stage. It's a big pleasure to talk about smart solutions, smart energy solutions. It's also a big pleasure for me to give a bit of a customer perspective here of IT, because we need a lot of IT and we need more than IT can offer us today. And hopefully, throughout this presentation, you get some of the ideas where we're working on. I will try to give real-life examples of innovation and IT, which helps us to overcome many challenges we have in the industry. So we'll talk about the energy challenge we have in the world. I'll talk about smart solutions for that across the value chain in oil and gas and renewables. So, yes, it's working. So innovation. We have learned accelerate things. So innovation builds upon innovation, builds upon innovation. In the end of the day, where we are on the planet is in a world where we have to really change things, where we have to really, in the end, try to beat Moore's law. And that's a big challenge we have ahead of us. So we will touch upon big data, we will touch upon big compute power, everything we need to do that. So these smart solutions are everywhere. We need them to find more energy, to produce more energy, and then to make sure that we can do that in a very environmental conscious way. These challenges we have are multifold. First of all, it's the pure energy challenge. Energy will double. The demand will double. Whether we like it or not, whatever we do, we will double until 2050, because we will have more people on the planet. And these people will move to cities. These people will need more energy. There will be more cars on the road at the same time. We have around 1 billion cars on the road today. By 2050, we expect it will double to 2 billion cars. That said, even if these cars are all electric, they still need energy. The electricity needs to be produced as well. So we have a big challenge together as a society. And we need every energy source on the planet to make that happen. So we have the need in a big scale for renewables. Solar, but also wind and water. Now Germany has been leading in Europe in this area. I think last year the German energy consumption was around 23% coming from renewables. At the same time, Germany is still the biggest hydrocarbon market in Europe as well. Be it oil, be it gas, be it coal. So all the renewable energy being produced, really important, a breakthrough I think definitely in this country, but at the same time the hunger is still bigger, so we need all the resources. So in order to transport that energy we need innovations as well. So one of the challenges of the industry in general is just the grid. In order to really cope with the intermittent production of wind energy, solar energy, you need a very smart infrastructure. And you need smart metering in the houses as well. Otherwise, it's not going to yield its benefits and it's not kind of going to be very efficient. So in Germany, you need to change your grid. Throughout Europe, we need to change the grid, and also in the United States. We need very smart solutions and investments in that. And is it all coming forward? It's probably not fast enough. So it's a real key area of concern, but also a key area of investment which we have to make. Then, we need still a lot of hydrocarbons to counteract that. And natural gas is by far the cleanest fuel. But it doesn't come easy. It doesn't come only from the Dutch Groningen field. It comes from Russia, it comes from Algeria, it comes from difficult places. So the whole supply chain needs a lot of technology, needs a lot of smart technology to get gas in here from Sakhalin or from whatever place we produce it. And then obviously our resources are not necessarily in easy places. So they're in difficult places. Also there, deep sea, Arctic conditions, wherever we are, you need smart solutions to make that work. So let's focus a little bit more on that. In Shell, we have recognized that we have to cope with that and that we are more and more a technology company. So we want to become the most competitive and the most innovative energy company. That's what our CEO has set out for us to do. First, the word energy company is important here. Second, most innovative. So we need a lot of IT-led solutions. We have 10 million customers a day, for instance, on our retail outlets alone, on the globe. And in Germany, one of our biggest markets, we have 1 million customer contacts. A lot of them are already kind of digitized. So we run a global SAP system just to cope with all of that, with all these customers. We are a truly global business as well, so we have supply chains over the countries. A Dutch customer calls for an order, ends up in Cape Town, the delivery comes from the German refinery, and the invoice comes from Chennai. That's what SAP enables for us. But that's just the base layer. So in order to proceed, in order to fast-track this whole innovation, we have decided to change the way we work. First of all, we have to cope with this challenge as a business enabler. So the energy needs 26 trillion. That's the estimate of the EIA. 26 trillion of investments in the oil and gas industry, in the energy industry in general, to cope with the demand up to 2050. We are investing 30 billion a year on year. Every year, 30 billion of capex goes into new projects. And quite a lot of that is technology, and quite a lot of that is IT. Per year, we invest 1 billion just in acquiring seismic data. Seismic data needed to find more hydrocarbons. And by 2016, we expect to have 450 petabytes of storage alone. We have a multi-billion a year IT budget and technology budget, so a lot of investments, also part of the 30 billion, go into IT and technology these years, and it's going up and up every year. We also have changed the way we work. Instead of having classic IT here and classic business here, we have created a unit somewhere in the middle of it. An entity which can drive IT-led innovation, which has people from the business, people from technology, so petroleum engineers, geoscientists, mathematicians, and the best and the brightest of IT together in one entity, to together figure out how we can drive IT-led innovation and how we can drive that innovation fast-track in the company. So this is all about hybrid organizations. This is about building down the barrier between IT and the business. So do away with this classic you're an IT and I'm a business person role. And it is really key to our success. To bring these people together, to have them together work on the latest generation, the next generation, the new innovation ideas we have. So where do we do this? Where do we apply all these smart solutions? I would like to talk a little bit about our value chain, from start to finish. Our value chain starts on exploration, just acquiring data, looking where we have to go next for gas or oil or other hydrocarbons. Then we have to build the facilities to produce them. This whole projects piece is huge in its own right. As I said, 30 billion a year, year-on-year, multi-year projects. Our planning horizon is up to 40 years for this. And the areas are not easy. They're in Sakhalin, they're in the deserts of Qatar, they're somewhere up north in Canada. So it's not just straight around the corner. Then we have to produce all of these. This is one of our latest deep sea rigs in the Gulf where we do a constant production. This is one of the bigger ones we have. Then you go into manufacturing, lubricants, refineries, chemical plants, and then it goes to our customers. In this example, it's retail, but it's also aviation, it's marine, the many customers we have. Now let's deepen a little bit this value chain, because there is exciting innovation and smart solutions everywhere. Just in exploration alone, The acquisition is not just happening on land, it's happening on sea, and it's getting more and more powerful. We are using a lot of smart solutions here, in particular these whole little sensors, both ocean bottom floor sensors as well as land sensors. They produce data sets of the scale of 10 petabytes easily, and they just need then to be worked. You see that in the corner of the slide. They need to be visualized, they need to be interpreted, and for that we need massive compute power. Not just a simple computer, massive compute power. So we're working here with already the best and the brightest of the industry, because the aim of innovation is a lot of co-innovation. It's not unique IP, it's working together with graphical companies, it's working together with the providers of high-performance computing, it's working together with the Intels of the world, the Ciscos of the world, the IBMs and the Hewlett Packards and many, many others. All these big data solutions and these big visualization solutions. Because to do the interpretation, we have our own proprietary data centers who do the high-performance computing. This is the high-end, and every rack you see here has the same capacity as the old Cray computers of the past. For those who are a little older, have seen these Cray computers, which need to be cooled down by liquid nitrogen, and they were the best in the industry 20 years ago. Now every blade here has the same compute power. We have thousands of these servers. We're in the top 5 benchmark of the industry, and it's doubling, nearly doubling every year. We found a 100x improvement already in the recent years by optimizing our software, for working with Intel on microcode of chips, but it's not enough. We need to find another factor 100. So I'm challenging the IT industry here. We are just in the need to move fast. And we cannot wait the normal Moore's law. We have to find other ways in the technology stack to fast track the improvements here we need just to crack these massively, massively big data sets. And then we need to visualize all of this. For a non-upstream exploration person, this might be a piece of modern art. This is a MRI scan of the subsurface, as we call them. So we're making massively big MRI scans. And the interesting thing is, when you look at visualizations, when you look at graphical processors here, you come together with the movie industry. You come together with the medical industry. You come together with rendering. You come together with the games industry, because we all need the same thing. Big data sets, visualized, fast track in real time. We have proprietary software to do that for us. It does a lot of our interpretation. This is one of the rare areas which we keep for ourselves, because it's really self-developed and very important for us to find the right locations, where to drill, where to produce, and how our reservoirs are structured. Then, when we move on in the value chain, we're into construction of our big capital projects. So you've all seen 3D modeling, but we're also extending this now to 4D and 5D modeling. What's 4D mean? 4D means the time axis. What is already available, what's not. We put RFID tags on all our components, they go to a laydown yard, and then we start to construct. Just our recent big production rig in the Gulf, the steel came from Japan, very special steel, very special grade, and production was hampered by the earthquake. The hull was made in Korea on the big wharf, and it was hit by a typhoon. And then we were starting to build the thing in the Gulf, there was a hurricane. So you need to cope with all of these planning disturbance. You need to cope with the whole supply chain across the planet to make that work. So we need the software. And the 5D then is the axis where you integrate it all with the supply chain, with your materials and so forth. So we're working with companies like Intergraph here to really get its supply chain end-to-end going and to develop the next generation of that software. Another piece of co-innovation and co-working we do. And then we're moving into production. This is the control room of one of our Gulf operations. And here you see our production platforms. The new ones are born smart, the old ones are not. Some of them are 30 years old, but we are trying to smart them as best as we can. Because uninterrupted production, safety is number one, and then uninterrupted production, proper maintenance are all the other things you would like to do. And the more we smarten these things up, the more reliable they become. So it's really important, again, to have smart solutions. Smart manufacturing is at the forefront of what we do here as well. Once hydrocarbons have been produced, we move them through the supply chain into our manufacturing areas. In order to do that in a safe way, but in order to also keep our manufacturing going, we have created a concept of a smart mobile worker. What's a smart mobile worker about? It's about using everything the IT industry can offer, touch-fit PDA, ruggedized, clever monitors, voice handsets, cameras on the helmet, where people can go into our plants, do inspection, ask advice from the control room, ask advice from experts on a completely different location, show the situation through the camera, and just also make their inspection reports, which are often mandatory by the regulators, on the PDAs instead of on the paperwork. So PDAs and the likes are starting to become very widespread in the industry, and not just for gadgets and for home use. So it is really getting integrated completely into the infrastructure in the IT landscape. Another piece we do is about drones. So we have to do a lot of inspection, flare stacks up in the refineries, or high columns or whatever. And then you have to stop production, do a lot of scaffolding, have someone climb high up with all the safety precautions, and then do visual inspection and make photographs. We're now piloting with drones. Drones with very special cameras on top of it, and then some software in the back office. Where these drones go up, they make pictures, they film, they check, and then data goes back straight into the control room to make us understand what the status is. Is this innovation? Well, drones were there and these cameras were there. The only thing we did is writing a little piece of software to bring it all together. And that's the other thing. Often innovation doesn't come from something big and unique, although we need it as well, but from existing things which you piece together in different ways. This pilot was run in the refinery here in Germany, which we have next to Cologne. So this is one of these exciting things we try to do as well with innovation, which saves us money, but first of all, make sure that our operators doesn't have to climb up all these high altitudes. And then last but not least, our customers. So how can we reach to our customers in this modern world? How can we reach them more individually? So we've created an internal apps factory. We are writing apps for the Android and the Apple world. We're making sure that people have station finders, that they can plan their tours, that they can keep track of maintenance of the cars, that they can redeem their loyalty, and in the future also can pay for their mobile phone on our retail outlets. This app is rather new. It's just launched in 30 markets. We have 500,000 subscribers already, and there's more to come. This goes through generations as well, obviously. You need to stay up with technology here as well. But so far, a very positive response from our customers. So again, a piece of innovation where we use the latest things on the marketplace and then try to integrate the Apple world with the Microsoft world, with the Android world, with our back office world, because a lot of the data on these retail outlets are residing in our big SAP systems. So, with all of that, there's a lot of collaboration needed and co-innovation. We can't do this alone. For the most part, we're after industry solutions, and we want to be a first mover here. We don't want to be late. We don't want to have unique IP, with the few exceptions I talked about. So who do we team up with? Universities, the academia. There are quite a number here on the list. But also big labs in countries like the Max Planck Gesellschaft in Germany, or labs in the United States and in other places. And then, of course, with the best and the brightest in the industry. I think I'm spending more time in Silicon Valley than I sometimes do in my home base, because it's really important to keep that co-innovation going. So you see names here like HP and IBM, Intel, Cisco, Microsoft as well. I just was with Microsoft a week ago. But also SAP, where we are trying to pilot the HANA solution, not for the standard stuff on top of an SAP system, but to see whether we can use HANA for our seismic data interpretation more than we do today. It's just a trial, but it's cool technology, and it has probably other use cases than more the classic was on top of SAP. So we have a whole ecosystem around this. It's just simply not able to do this alone. We're just not big enough to do that, and you just want to tap into everyone's R&D. Just a few more examples of what we do here in strategic collaboration. One on high-performance computing, as I said, where we're big here, but it's not good enough. We need to speed up, so we're trying to find ways to speed this up through the stack, both on the graphical side as well as on the compute side, as well as on the storage side. On the right-hand side, the serious online environment is what we do with Intergraph to connect up drawing offices, engineering contractors, equipment suppliers, integrated service providers, to connect them on the data and the drawing level, to make sure that they all work from the same hymn sheet, to make sure that they all design to the same purpose, and also to make sure that we have one and the same data environment, because an engineering process from start to finish is just a constant altering of the same data. And then a certain representation might be a drawing, might be a parts list, might be an order. So we're rolling this out quite quickly now as well. More examples here are in the drilling space. We have to drill many, many wells, particularly at the moment in China. So in a joint venture with the China's national oil company, we are working to fully automate our rigs, such that the drilling engineer can do 10 rigs in parallel, working from a back office, remote operation, and SCADA drilling, i.e. programming the rigs beforehand, such that they know what to do. This is enabled by a fast-track innovation we do at Cisco. We call this a rig in a box, and at the end of the day, it's a little box who controls the entire rig. Obviously, you need very reliable telecoms for that as well, and then high-end telecoms is another need we have. But a year ago, we had nothing. We worked very intensively with Cisco, and now we have something which is really meaningful for us. Just an example. White space. Okay, here's coming. The whole challenge is, apologies, there's something wrong in the sequence here. The challenge is to get, no, let me just skip this one. The challenge is to innovate the way we innovate. So all the companies in Silicon Valley and in the IT industry in Europe and everywhere have their own R&D budget. We have our own R&D budget, but if we team up in a constructive way, do co-innovation in an open way, we can tap into each other's big budgets here as well. So I think the companies we work with have 35 billion a year in R&D budget, which is roughly 30 times more than we spend on R&D. So it's really important to tap into that. It's also really important to tap into other sources. Here it comes. Well, it seems to be a little out of sequence. Let's just skip the slides and just talk about this a little. So we are tapping into our own employees in a more constructive way. One of the things we got from that is the whole concept of a floating LNG vessel. A floating LNG vessel is a complete LNG plant on a vessel, which we're now building for our Northwest Shelf project in Australia, to produce the gas in the deep ocean and then ship it off straight to the markets in Korea, Japan, China, and wherever else it's needed. That whole idea came from our own employees. Then we have our Game Changer program, where we work with little companies together. We put the resources in, sometimes funds in, they do that, and work in co-innovation. Sometimes we don't use the ID, but we allow them to grow further. And sometimes we do use the ID ourselves. Then obviously we are trialing crowdsourcing. And it's amazing when you put an ID or a thought or a need or a challenge on the marketplace, how much response you can get from the general public. Bright ideas are coming in. And then the fourth one, of course, we have all sorts of prizes as well. We give to academia, we give to people who do cool innovation. And last but not least, we're also tapping into the venture capital world. We have own venture capital funds now to fund small startup companies, but we're also teaming up with venture capitalists in the valley and other places to help them to spot companies, but also look at their already invested base. Is it of interest to us? And sometimes we co-invest. So all the channels are needed. Your own staff, general public, smaller companies, venture capital, team up with R&D with big companies in the IT industry. It's everywhere. And that, I think, is the challenge. And there's also the sharing part of the innovation piece. The challenges the world is facing, the challenges the company Shell is facing are so huge that you cannot solve them alone. You need to work together, you need to team up, and you need to make sure that whatever comes out of it is shareable across the enterprise. Again, we want to be an early mover, because we want to be the most innovative energy company on the planet. But we don't want to keep it for ourselves alone. We are happy to share a lot of these solutions as well. So with that, I've come to the end of my speech. I hope from this short talk you understand that they have huge challenges, that we have huge challenges for the IT industry, that we want to work together to be the most innovative energy company on the planet, and that there are many, many, many bites in a barrel of oil or gas. Thank you. Danke zeer.
Mr. Dorland, thank you very much. We've got time for maybe one question. We're waiting for our panelists to come up. I thought I would then take the opportunity to ask you, talk to us a little bit about this notion of sharing at Shell, the notion too of crowdsourcing. You've been in the business for a while. How different is it today than even if you were looking at the business even just 2 years ago? What are the biggest differences you see?
I think the whole approach to innovation has changed. The realization that IT-led innovation is at the heart of our business, the realization that Shell more and more morphs into a technology company, more than anything else, and that technology is our future, I think has changed the whole approach to this. Has led to the creation of this separate entity, which I was describing, technical and competitive IT, next to the regular IT, next to R&D, to drive the IT innovation, but also gave us the challenge to get more ideas in, and get them through faster. And you want to get them through faster, you need to work together more. So that's why we pull in academia, where we try to pull in general public, we try to pull in more of our own employees' wisdom into all of that. So I think it's a rethinking of what really matters in the company, it's a rethinking of the role of IT in that company, which made this big change happen.
All right, very good. Mr. Dorland, thank you very much for talking to us today.
Thank you.
Thank you.
Danke.
Okay, we've got a couple of minutes before our panel discussion